Hi guys, welcome to the channel. In the previous lesson, we discussed what is matter and what are different states of matter and how these states of matter can be changed. In this lesson called Is Matter Around Us Pure, we shall discuss the matter in our surroundings. Is it pure or is it a combination of different mixtures? Today, I want to change the idea, the notion of the pure substances that we have. Let me take some examples to show that. Right? I want you to consider these substances that you see around yourself every day. For example, milk. When I say milk, it will come to your mind that on the packets of the milk it will be written as pure milk. Right? It will be written as pure milk or pure ghee, pure butter, like that the things will be written. But some people, what they do, they are going to add water to the milk and you can say it is not pure anymore, it is adulterated. So in a general meaning, the meaning of pure is something which is not adulterated. It means nothing is added to make it something else. But milk, according to you, it might be a pure milk, it might be pure milk, but not according to the scientists, not according to the science. The milk is not a pure substance because the milk is made up of so many things like protein and fats, vitamins, so many things, right? So milk itself is basically not a pure substance because it consists of so many other substances like fat, proteins and all, right? Similarly, ghee, you may have the pure ghee in your home which is written as pure ghee, but according to science, the ghee is not pure because it is also made up of the fats and oils. Similarly, in the case of butter, if you look at salt, if you just take a grain of salt, is it pure? Is it pure? Yes, the salt is pure. Why would you say the salt is pure? The salt is pure because the salt is made up of only one type of particles. You take a grain of salt, everywhere you will find NaCl. Everywhere you will find NaCl. If you take a glass of milk, if you just extract, you may get proteins, you may get fats. So there are other substances also which are involved. But salt, if you take, there are only one type of particles involved. Where everywhere you are going to find NaCl. This is the difference I want you to understand. Even if you take water is just H2O, so you can also say this is pure. So juice, you drink any juice, so they may give it as a pure juice, but it is not pure because so many things are involved. For example, if you are using apple juice, apple milkshake, so milk is involved, milk itself is not a pure substance, then water will be involved sometimes, then apple is involved, so many things are involved. So this is not a pure thing. Sugar, is it pure? If you take the grains of sugar, all the particles, all the grains of the sugar are made up of one type of particles. If you take seawater, you can see there are so many dissolved salts into that. So obviously, seawater is not a pure substance. Then minerals, they also have dissolved metals. That means minerals or they have dissolved particles. So that means these minerals they are also not the pure substances. Similarly, if you take soft drinks like Thumbs Up, Pepsi, or Coca-Cola, anything. So in that most of the percentage of content is water. Then we have the carbonic acid. Right? So this is also not a pure substance. Okay, so let me just list the pure substance we have here, what are the pure substances we have here? Milk is not pure substance, but we call it as a mixture. We call it as a mixture of so many things, right? So here, the salt is a pure substance. Salt is a pure substance. Then water is a pure substance. Then what else is pure substance? Then sugar is a pure substance. Rest of the things, milk, then ghee, then butter, then what else you have? Juice, sea water, and minerals, and soil, right? All these are what? They have the dissolved contents. They are combination of two or more type of substances. So this we can say mixtures, and this we can say pure substances. So how can you define pure substance? So how can you define pure substance? Pure substance are those substances which are made up of only one type of particles. They are known as pure substances. I hope you understood scientifically the difference between the pure substances and mixtures, right? Then what is a mixture? If something is not pure, then it is a mixture. That is nothing but it is a combination of two or more pure substances. That is called a mixture. Okay, so this is the basic difference between pure substance and a mixture. I hope you guys understood this. Now let us discuss more about mixtures. Because now we came to know that pure substances are those substances which are made up of only one type of particles, and the mixtures are nothing but they are a combination of two or more pure substances are said to be mixtures. Okay, now I want you to conduct an experiment. Take a beaker and put water into the beaker. Just take common salt. Then this is water, right? So suppose I'm going to add more water. Then just dissolve it completely. So you can see that salt gets completely dissolved into the water. One more experiment I want you to conduct. In that, also take a beaker and fill that beaker with the water, and this time you need not put salt, just put some chalk powder. I want you to put chalk powder, right? So I want you to observe after some time. This is water, this is water, right? After some time, if you observe this solution of salt, you can see that the salt has completely dissolved into the water. You take any place. You take this place. You take water from here, or you take water from here. You take water from here or water from here. You take water from anywhere. The amount of salt and the water is same. The amount of water and salt is same. That means the salt has completely dissolved into the water. That means all the particles of the salt have been uniformly distributed in the water. All the particles of the salt have been uniformly distributed in the water. That means you take any drop of solution, you will get the same amount of salt particles. That means the composition is uniform. What you can say? The composition of this solution is uniform. or you taste any of the water, it is going to taste the same. Similarly, what happens after some time to this chalk powder? What happens is this chalk powder is going to settle down at the bottom. Is going to settle down at the bottom after some time. Yes or no? This chalk powder is going to settle down at the bottom. Now you take the water from the mixture. Take this mixture from two different places. So if you take from here and here, what about the composition? The composition is it going to say here more chalk is there, you will get more chalk particles. More chalk particles. Here the particles are less chalk particles you are going to get here. That means you take any of the particles in this mixture, you get that the chalk particles are not uniformly distributed through this mixture. Okay, the chalk particles are not uniformly distributed through the mixture because the chalk powder particles, they have been settled down at the bottom. You can see more chalk particles here compared to here. That means the composition of this mixture, it is not uniform. Okay, so I can just write it as composition is not uniform. Composition is not uniform. Okay, so these mixtures which have the uniform composition throughout the mixture, those mixtures we call it as homogeneous mixtures. We call it as what? Homogeneous mixtures. Homogeneous mixtures. Right? We call it as what? Homogeneous mixtures. And these mixtures which do not have uniform composition throughout the mixture, we call them as heterogeneous mixtures. We call them as what? I'll just write it here. We call them as heterogeneous. Heterogeneous mixtures. Okay, so these are the two types of mixtures. One is homogeneous mixture and one more is heterogeneous mixture. Homogeneous mixture means in that mixture the salt has completely dissolved, which means the composition is uniform. Those type of mixtures which have the uniform composition throughout the mixture, they are called homogeneous mixtures. The example is salt and water. Salt in water, right? Then heterogeneous mixtures are those mixtures in which the composition is not uniform, which do not have a uniform composition. They are called as a heterogeneous mixtures. The example is chalk powder in water. Okay, I hope you understood the difference between homogeneous mixture as well as heterogeneous mixture. Okay, thank you.